Alright, this is the Mix It Up demo. This is part A of the Mix It Up demo. What I have here is a beaker of water and I have syrup. I'm just going to put a little bit of syrup into the water there. You can still see it in there. Got a glass stirring rod here. I'm just going to be, as the demo's name implies, mixing it up. Alright, and the syrup has completely dissolved. Now what I'm going to do for part B is I'm going to be adding some oil, which I need to find. Okay, so this is Mix It Up part B. I've got my beaker of water, and now I'll be putting some vegetable oil into the water here. And now as we stir with the glass stirring rod, we can still see the oil. It does not dissolve. So the property of water here is going to be polarity, because likes dissolve likes. And we've already learned that water is polar, and syrup, which has sugar in it mostly, is a polar molecule as well. So because the sugar is polar and because the water is polar, the sugar dissolves in the water and we can't see it anymore. The oil, on the other hand, is a nonpolar substance. So because of that, the water can't dissolve the oil. So the oil remains separated from the water. I would need to use a nonpolar substance to get the oil to actually dissolve. Okay. Alright, so what we're going to be watching here is Slurpin Celery. What you see is a time-lapse video of 4 white colored flowers sitting in different colored water. As you can see, over time, the colors of the flowers actually change to the color of the water. The reason this occurs is because the water is moving up the tubes that you find inside the stem. This is an example. The property of water is adhesion. You've got water that's attracted to the molecules of a different substance in the stem. Now, over time, the water keeps moving up the tube and eventually ends up in the top of the plant, in the flower. This is called capillary action. Capillary action is anytime water can move up a tube on its own due to adhesion. You can see this in all root structures. So this is the way plants all move water up the stem to get water. You can also, if you've ever been to the doctor and you've had your finger pricked, so they're going to take a blood sample, they hold a tube to the blood and the blood goes right up the tube. And ironically enough, those are called capillary tubes. So these are all examples of capillary action, which is due to the property of water called adhesion. And that's Slurpin Celery. Alright, this is the cat's meow. So what we're looking at here is a petri dish filled with milk. And what I'm going to do is I'm going to put 4 drops of food coloring. There's 1. 2, 3, and 1 on the other side. 4. Okay, so go ahead and make your initial observations. Alright. Now what I'm going to do is just take a toothpick and the end has some soap on it. There we go. So that is the cat's meow. Now the explanation of this is basically you've got 4 drops of food coloring that's being held in place by the hydrogen bond and cohesion of the water and the milk. Once the soap is added, the hydrogen bonds are broken, and it allows the water plus the food coloring to be able to flow around. So at first, the cohesion keeps all the food coloring in place because all the water molecules are stuck to all the other water molecules, so it doesn't let it flow around. As soon as I add soap, those hydrogen bonds are broken, and then everything can flow around wherever it wants to go. Alright, what we're watching here is Nifty Needles. What you're going to see is this gentleman is going to be wiping first the oils off of the needle so that there's no oils on the needle. And then he's going to be placing this needle perfectly horizontal in a glass of water. To help him do that, because that's kind of hard to do, he's going to put it actually on the paper towel, as you can see here, and then he's going to carefully place this into or on top of the water. And I'll let you watch and see what happens. So now he's going to touch the paper towel and let it sink away from the needle. You can see now that the needle is still floating on top of the water, and now he'll be removing the paper towel. And there we go. So now we have the needle floating on top of the water. And that's part A of Nifty Needles. And now what this person's going to do is they're going to add a drop of soap into the water. And there we go. And what's happened now is that the actual needle fell to the bottom. Alright, so what's actually going on there? So by basically putting the needle horizontal, you can spread out the weight of the needle, and the surface tension of the water then can hold the needle up. Okay, so the surface tension is caused by cohesion. So that's the property of water. Cohesion is where water molecules are going to stick to each other. And because the weight of the needle is spread out enough, the actual force of cohesion is stronger than the force of gravity pulling down on the needle. And thus the needle stays at the surface. For the second part, still the same property of water as cohesion, but by adding soap, you break the hydrogen bonding. So what's holding the actual water molecules together is broken, and then the needle sinks to the bottom because nothing's actually holding it up. Alright, this is Ninja Toothpicks, and I've got a very special toothpick here. We've got several drops of water on wax paper, so you can see that they're all nicely dropped up there and forming nice drops. And I'm going to use the side of the toothpick here that does not have anything on it. And when I do that, nothing really happens. I'm sticking it in there, and it's just like, look, that one even merged. It's kind of merged together there. Now what I'm going to do is I'm going to use a magic side of my toothpick here. And the magic side of the toothpick has soap on it. And when I do that, it's almost like popping a bubble. And there we go. So
happening here is you've got, obviously, wax paper. Wax is a lipid, it's non-polar, so the water really likes to stick to itself in terms of cohesion there. So it kind of balls up into a nice drop. And it's going to stay that way no matter what we do. You can even do some other cool things here with this. Like I can put this drop over here. You can even see it moves. It kind of moves as a big drop. If I take my toothpick, I can even kind of pull it around. There's a little adhesion there. It sticks to the wood. So you can kind of see it like, almost like it's sticky, like it's syrup. So that's cohesion. And then when I use the Ninja side of the toothpick, which has a little soap on it, it breaks all that hydrogen bonding and it just kind of makes it more fluid, like a non-polar substance. And now it doesn't, stick back together. So the explanation here, the property of water is cohesion. Explanation very similar to when we did the cat's meow. The soap breaks the hydrogen bonding, causing the water